Okay, so the set of simultaneous linear equations does not have a unique solution. So when they say does not have a unique solution, that means the determinant will equal zero. Equals zero, and that means it does not have a unique solution. So what you've done here is, this is called matrices. This is the setup. So when you've got simultaneous equations, you've written it how we set it up. Now, if we were going to solve these, so when we're solving it, what we're actually doing is trying to find that unique solution. So remember back, so when we solve it, we actually put in that this matrix here, we would actually find the inverse of that one and times it by the end one, the 10 and the 6. So this one here is what I'm calling is the inverse. Okay, so the inverse matrix, so if we just go back to our theory, if we had a matrix that had, say, A, B, it looked like this. This was a normal matrix. If we were finding, and I'll just call it matrix A, if we were finding the inverse of A, the way we would do it would be, we'd have 1 over the determinant, and then we swapped those numbers around and we made the B and the C negative. So we also had this part here, the determinant. So, and the determinant was found by going the A times the D minus the B times the C. Okay, so what happens is, because this formula for the inverse has the determinant in here, that bit there under the fraction, if it equals 0, that's why we can't have a unique solution, because if you have a fraction with 0 on the bottom, it can't be done. So what we're going to do in this question, if we find the determinant of this matrix here that you've set up just there, so if we find the determinant of that matrix, we want it, if it equals 0, then we will not have a unique solution. So we'll go do that. So the determinant of that matrix would be A times B, that number by that number, minus 4 times 18. So we get AB, and 4 times 18 is 72. Okay, so if we're going to have no unique solution, we need this determinant to equal 0. So therefore, we need A times B to equal 72, because if we had 72 minus 72, that will equal 0. So what we're going to do up here, you can see that 2 times 36 does equal 32. So that would be, that will create it to be 0. If you have the next one, 3 times 22, that would be 66. It wouldn't work. So all the rest won't cause the determinant to be 0. So just that first one. Sorry.